All right, we still got a few more minutes to go, but hello and welcome to everyone who's just joining us now.
We'll get started in a couple of more minutes.
Yep. We still got 1 minute until 2:40, so my god, what is this endless screen share?
Infinite screen share.
All right. Lox, your mic doing all right?
Yeah, you can hear me?
Yeah, okay, cool. All right, nice. It is 2:40
Cool, we can get started.
and all right, so if people are still coming in, that's all right. We're going to just be introducing ourselves to start off, so we won't be missing too much, but
Right, so hey guys, welcome to our command-based programming session. I'm Lakshman Bani, Team
um,
67 software lead.
I'm Claire. I'm also from Team 670, and I'm the VP of Development.
All right, so big ideas. There's a couple of parts to command-based programming. So, how do we represent parts of a robot? Those can be hardware sets, for example, shooter or drive-based. How we represent actions that a robot can do. So those can be commands, such as shooting a ball or climbing. And finally, how do we control when and how a robot can do these actions? So, let's say if you trigger a button, that's when it has to do. So, how do you actually control when and how it happens?
So, in other words, what we're looking at today is just sort of one way to structure your entire robot program. That means representing all parts of a robot system and getting it to work together in code. And as you'll soon see, command based programming, this is one way you can do it. It is probably one of the easier ways to represent things, and thus is like pretty commonly used for FRC. And so, yeah, command based programming provides a rather clean and effective way of structuring and writing your robot code. So, you're going to want to represent parts of the robot. You can represent those. You're going to want to represent things those parts can do, whether on their own or together, as, like, part of an entire system. That's something you can do as well. And command based programming is actually an example of declarative programming here. It emphasizes what your program should do rather than how, which gives you have a lot of room to define your different parts of your robot system and the actions they can do, the properties they can have. So yeah.
All right, so a part of the command-based programming was how do we represent parts of a robot?
Oh,
And
one really quick thing. I'm sorry, but just an FYI, we will be showing some code samples throughout this talk. The code samples will be in Java. However, this concept, the idea, it's not specific to any language. Although this is also what the WPI lib library allows you to do. That has code for Java and for C++, so you should be fine.
there's also Python if you want to try, but yes, Java and C++ are the main ones. Well, so anyways, how
Yeah,
do we
sorry.
represent parts of a robot? So subsystems is the way to do it. subsystems basically are parts of the hardware, things that the robot has, which have to be controlled. For example, drive base, shooter, indexer, turret, intake, climber, etc. So, looking at this picture, some subsystems could be climber. So each of the subsystems have their own classes. So climber has its own class, shooter has its own class. Then there's indexer, which also has its own class, intake, own class, and then drive base again,
Yeah,
own class.
you'll see this represented in you'll see this represented in code, but when we do look at code samples, you'll see that when you want to code a subsystem, you extend the superclass subsystem, and that in that you can define the properties that make every part of the robot different. But yeah.
Yeah. And each of these classes have their own methods. So climber, let's say it has to go to a specific point, or let's say it has a method, say is it at the final location. So each of the subsystems have different kinds of actions in the subsystem class itself.
Any questions about subsystems real quick, or?
Put them in the chat or open up your mic and you can ask. And Claire,
someone asked, can you record the session? Yes, I am recording the session. Yeah. Does not look like we have any questions in the chat, but feel free to ask. Feel free to ask any questions you have. Yeah.
All right, cool.
Recording format. Right. So subsystems let us define the parts of the robot, but well, how do you define the things the robot can do, right? Maybe your intake can go pick up a ball, you can lift your elevator, or you can drive forward. Well, that's where commands come in, and the commands let you describe actions a robot can take. So often, but not always, your command is going to be related to a subsystem or a bunch of subsystems. For example, when you drive, you need the drive base, or when you intake something, you need the intake. So your command for doing those actions would require the drive base subsystem or intake subsystem, and as you'll soon see, that's something you can define in code. But again, like, since you can use a command to do any robot-related action to, schedule and have it happen at some point, it could even be reset a sensor or check some value. It'll make more sense when you look at some code samples, but when you create a command, there's a lot of different kinds of commands you can make, and when you create it, you can take in parameters or not. If you're taking in subsystems when you create the command, then you should call the add requirements method to add this subsystem as a requirement for the command. In other words, when you run this command, you need to look at that particular subsystem. And another important thing to note is that any kind of command you write is going to have these four methods. One is initialize, one is execute, one is end, and one is finished. And we'll go into a bit more detail later, but the names should give you a pretty good idea of what they do. Initialize is what gets run when you're preparing to start executing or running this command, and you use it to do anything that's like setup related. Maybe you want to define some value before the action starts happening, for example. And execute, meanwhile, runs every cycle while the command is scheduled to execute. Pretty self-explanatory, but like keep in mind whatever is inside that method will keep running until the command reaches some endpoint, which is what is finished will tell you. It also gets checked, and it's basically, are we here yet? Are we here yet? Are we here yet? Are we done? This is also getting checked every cycle while the command is running. And when it does return true, then we move on to end the command and do whatever needs to happen there in the end method.
Yep. Also, add requirements. The reason you need it is if you don't do that, maybe another command's already using that subsystem, so your command won't be able to use it, and that's a problem. And that's why you do need to do this add requirements thing.
Someone asked in the chat, are we going to be able to get the PowerPoint? We'll have resources linked at the end if you'd like to do some further reading, and if you want to just review this information later, so.
Yeah. Any questions before we move forward? Because commands is a big thing.
There's a reason it's called command-based programming. Let me just check the chat. Right. Doesn't look like we have any questions now.
Oh, all right. So command types. There's basically four different ones, but there's more, and we've linked them in the resources, so you can read more about them. But first on command base, it's the most simple command. It's the default command, and an example is just climb. So go just climb up. Second one, instant command. So through the name, you can see it runs initialize and then ends immediately. So it's quick. And an example could be deploy intake. So you just want to deploy it, and you're done. There's no execute. There's nothing happening in the loop. Third one, run command. This one runs repeatedly, runs execute repeatedly, and there is no end loop. So an example would be teleop control. You want it to run throughout the whole match. You don't want it to end, which is Xbox Strife. So that's run command. And finally, wait command, which ends after a period of time elapses. So let's say time drive. You want to drive for a specific amount of time, just straight. So that would be time drive.
So when you're writing your code, think about like what kind of actions what kind of actions you might represent with like these different kinds of commands, right? Um, Depending on what you want to do, you're probably going to pick a different type of command or even multiple commands. And that's just, something useful to keep in mind.
Yeah.
Like when you hear command, think action, something a part of the robot can do. So some examples, if you guys have any examples, feel free to put them in the chat. Oh, we got a question really quick. In a subsystem, are the actions defined, and then when you execute, you choose the action? That's a really good question. So it's probably going to make more sense when you see a few more code samples, but that's actually a really good question because when you define the subsystem, you want to define sort of just like properties of this thing, or sort of like functions that only apply to this that can get a value maybe, or set a value, or calculate a position, things like that. That's the kind of stuff you would want to be putting in the subsystem class. However, any action that you want to schedule to happen, like at a specific time or a specific trigger, that's something that you would write in a command. Because as you'll soon see, we have this thing called the scheduler, and that's responsible for handling any robot actions or commands. That's something that takes a bit of practice and takes a bit getting used to when you start writing code like this. Deciding where to put some specific code. Do you make a command or is it a method? And a general guideline is like if the subsystem is going to be doing anything, for example, something rotates to a specific angle, and that's an action you want to schedule, like, oh, when I press the button, it rotates to this, that would be a command. But if it's just a method for calculating how far to rotate and returning some value, that would be something you put in a subsystem. Basically think of every command as a separate action that you can start to execute. Charlie, does that clear up your question, or? Yeah, let me know in the chat. Okay, yeah, thank you. So back to commands. So like I said, think about them as actions or procedures you can do. For example, if you have a drive base, you could drive for a certain amount of time or distance. And while I'm saying this, you should probably think about what kind of commands these would be. If you had an intake, you could deploy the intake, like just drop it down, or you could run it to pick up a ball or something. Or with a climber, you could climb, and on and on. Like, feel free to think of your own examples. And in these cases, these commands are specific to a subsystem or to a group of subsystems. Like, you could have a command that uses multiple different parts of the robot to do something. Right, and it's a big action. Yeah. And,
All right. All right, so here's our time drive or a sample time drive. So like we mentioned before, it should be of the wait command group type because you wanted to do for until a certain time limit elapses. And so for time drive, we do need drive base, and that's where we mentioned over here add requirements drive base because this command needs it as a requirement. Other things that we're taking is seconds and power. So for how long and at what power or speed. So when you see super seconds in Java, that just means it's calling the wait command and on seconds. So that means it's gonna run it for the number that you input over here. Finally, execute is where it's actually running it. So tank drive makes it go forward. Add left power for let's say power is 50, so left will be 50, and right will also be 50, which means it's going straight. And finally, to end it, you would make it stop. So drive base.stop. You can see the initialize and is finished because they're actually in the wait command class. They're just basic stuff. So initialize is where the timer actually starts, and is finished is when the timer it just checks if the timer ended or not, and that's why it's default and it's in that class and it's hidden.
First of all, I got another question from Charlie. Thank you so much, by the way. These are good questions. So Charlie asked, if I had a piece of code that found the location of an arm, that would go in the subsystem, and there would be a separate command to move it. Yeah. So, like, finding the location of the arm, that's a property, right? That's something you might check when a command is happening, like, hey, am I at my location yet? Versus, you can think of it like as a utility, right? Versus moving the arm itself, that's something you could schedule to happen at a certain point, right? Like, oh, I press the button and the arm moves, or I get to this point and the arm moves. That's an action that you want to schedule to happen at some point, right? So that would be a command, like move arm, right? Does that make sense? And yeah, this is all in Java. Again, like, thank you so much for the questions.
Yeah. Clear?
And here's another example of a command base. It's like when you hear command base, just think of like a simple action. In this case, we have an intake and we want to keep running the intake. So what we can do is, well, first, what do we need? We need the intake subsystem. So we define that as a field, and we also add it as a requirement for this command. And as you notice, like, we take in a parameter for whether or not to run the intake forwards or backwards. When we start this action, that's whatever is getting called an initialize, right? So originally we want to spin it in the opposite direction and then spin it back up. If that's how we want to do this, for example, that's something we can call an initialize. It's going to start going backwards for a little bit, even before the action itself starts happening for real. And after the command gets initialized, it gets scheduled. It starts executing, and we run the intake.
And again, is finished and end both are end
So
commands.
someone asked about the drive base, the time drive example. Drive base dot tank drive. Tank drive is a method that we have in our drive base class. It does exactly what it says on the tin, and we did not implement it as a separate command. However, that might be something interesting to think about, like how you might want to structure it, right? And we'll also, that's kind of would also go into the question, like, can we schedule a command? I mean, can we have a command call another command? And the answer is yes. But yeah, in this case, we have it as a separate method in the subsystem.
All right. So next thing up, command groups. Basically, they're a combination of multiple commands. You could group commands together, and it allows code to be cleaner and simpler. So commands are coded independently, and then command groups combine them. They're similar to commands in the way that you could also include them in other commands or command groups. So you could make command groups of command groups, and also they can be called just as regular commands. So they're recursive.
Yeah, so when in doubt, just think about command groups like a procedure or sequence that requires like that involves a lot of different actions. And you'll
But
see like,
they're trying to solve a common task or something. So let's say you wanna pick deploy an intake and start running the intake. So that would be a command group to similar actions.
yeah. So like in the vein of, next slide? Or is it just not showing up? Yeah. So in the vein of like a procedure or routine, one way we could make a command group is one where the actions in it happen sequentially. First I do this thing, then I do this thing, then I do this thing, and it happens only after the thing before it has completely finished. If you want to do something like that, you could use a sequential command group, which is, wow, you add your commands in a sequence. For example, first I deploy the intake, and then I run the intake, and then I stop the intake. They're three separate actions, and they need to happen in this order. That's a situation where you might want to use a sequential command group. What other examples can you guys think of for like cases where you might want to use something like this? You can feel free to put them in the chat. However, that isn't the only way you can have some kind of routine, right? And that brings us to
Parallel command groups. So with the parallel command groups, you can do two things together. You can run two commands together. So an example would be distance drive and rotate to intake position. So that would be going forward and deploying your intake and maybe starting up the intake together. So that would be a parallel command group. They're happening together so that you can save some time.
any questions about these?
Command groups, any of the sequential or parallel, any questions?
And like and are you able to combine parallel and sequential command groups? This is a really good question. Like, yeah, you can, because if you think about it, every command group is like a big action, right? Your action is doing a lot of smaller actions in some order. So yeah, you can have a command group in which other command groups or sequences are happening. Like for example, you could write some code where you're, I don't know, driving a path at the same time as you're intaking a ball and indexing it and preparing it to shoot, right? You could think of this as like two separate groups of actions, but you could have them happening at the same time. You could have like two sequences running in parallel, and that would be an example of when you could combine command groups. Or alternatively, even inside one command group, you could have two things happening at the same time as another like two things are happening in order as something else is happening at the same time. It's there are different ways you can like combine commands to make more complex actions, and yep, that is definitely valid. Does that answer your question? All right, cool.
All right. So next thing, we talked about subsystems, so their hardware, each have their own class. Then we talked about how to control them, so commands. But how and when do we actually run the command? And with that comes a scheduler. So that commands are called through the scheduler. You add them to it, and it runs it in the order that you added it. So let's say you first told it to go forward, time drive. It runs that. Once it's done with that, then it runs the next one. Let's say deploy intake, and also depends on the command group. So if it's a sequential one or a parallel one, it could do stuff based on that. There are two conditions though for whether a command is scheduled or not. So one of them is whether the requirements are available. So if there's subsystem requirements, are those free to use? Is no other command using it? Second condition is are other commands interruptible? So let's say another command is using the subsystem that you actually want to use for it, so it's a requirement. Um, is that command interruptible or not? So let's say you have your requirement available, it's free, no other commands using it, so it will get scheduled. However, if your requirement's not available, let's say drive base is being used by some other command, though that command is interruptible. So what the scheduler does is it interrupts the old command and schedules the new one. The third situation could be is your requirement available? Maybe not. Dry base is being used by something else. Is that command interruptible? No. That command could be more important. So your new command isn't scheduled, and the old one still keeps running and using the dry base. This is also a big thing. So if you have any questions, put them in the chat.
Right. So, in case like we were describing like the scheduler in the previous slide, but here we have a flow chart of how the scheduler works and we can follow it, starting with checking if, hey, is this command that we want to run already scheduled? If it is already scheduled, then, well, we don't need to worry about it. It'll run when it is time to, or when the conditions are met. If it hasn't been scheduled, then it checks, hey, my command requires this subsystem and that subsystem. Are those subsystems being used right now? If the subsystems aren't being used, then okay, you can run this command. If the subsystems are used though, and there's a conflict with another command, you check and say, hey, can we stop the other command and run this one? If so, then we can interrupt those commands and keep running this one that we tried to schedule. If we can't stop it, then, well, unfortunately we can't do anything right now because all the subsystems are being occupied, so to speak. With that in mind,
We can also put an example on it. So let's say time drive. Did we already schedule it? Yes. Do nothing. No. Is the drive base available? If yes, then run the command. If not, let's say another command was running. Let's say distance drive was running. So go forward for a certain amount of distance. Is that distance drive interruptible? Yes. Then interrupt distance drive and then run time drive. But if distance drive is not interruptible, then unfortunately your time drive command can't run.
okay. And one thing that might have come up that just is a common question, so I'm going to clarify it here, is if you've noticed in the command, there's a method called end and a method called isFinished. And I've noticed that sometimes people tend to get them confused. So just to clarify, the isFinished method, it returns something. It returns a Boolean, actually, so a true or false value. And this isFinished method gets called every cycle that the command is running. So as execute is happening, the action is being done. The scheduler, this thing's scheduled to run. The program is also checking, hey, have we reached our endpoint yet? Should we keep doing this thing, or is it time to stop? And for example, in isFinished, you could be checking like, did I get too close to a wall? Or did I reach my target distance? Or did I move my arm to the point that I want it to move to? Or did I already intake a ball? Or whatever, right? So in isFinished, you'd be checking for these conditions. And if the conditions aren't met, then you should be continuing to do your action, right? You should continue driving or continue moving or continue intaking or whatever. If your isFinished, though, if the conditions are true, that means you've already gotten to your endpoint. The method will return true, and at that point, we call end to stop this command, finish off this action. So maybe setting the motor power to 0, or resetting some counter or whatever. Whatever happens at the end of this action when it's done, that's what you do in the end method. It runs once after the last call of execute.
Any questions regarding end versus isFinished? Put them in the chat.
I think someone asked, can you include bulliness, for example, to make the robot go back if it goes too close to a wall? I'm not 100% sure what that means, but if you're asking about like a condition, right, like do something until this happens, then I'd say that's something you put in isFinished. Like, you can check your distance against the wall, I guess, and if you're too close, then you stop or you do something else.
Just talking about how all the parts of the command run. So first thing that happens is initialize, happens once, then it goes to execute and
Yeah, maybe.
runs that once if initialize was successful. After execute, it goes to is finished. Is finished returns a boolean. So if true, then end. So end is called. But if false, then it goes back to execute. So execute and is finished are in a constant loop
Yeah.
until is finished returns true or says it's finished.
Mm-hmm. So in general, if there's a condition that you're
And
checking to see if this action should keep happening or not, that's something you want to be checking for in is finished, right? It will tell you like, yeah, we should stop here, or nope, keep going. I hope that cleared it up. I'm sorry if I didn't get your question, but
all right, so here's an example. We're gonna do some stuff with it though. So here's a start shooter command where we just ask the shooter to start up and keep doing it until shooter's up to speed. So let's say we want to go up to 5,000 RPM. It's gonna keep running until it's at that speed, and then it's gonna tell the logger that shooter's up to speed and it ended. Right now in the chat, can you guys identify which type of command this is? So when we talked about the four types of command types: command base, run command, wait command, and one more.
yeah, let's see. What are you guys thinking? Someone said command base, and Alyssa and Charlie both agree. All right.
All right, cool.
Very cool.
Second thing, right now in the chat, put one of the requirements that this command is using or needs.
Right, yeah. The shooter subsystem, all of you guys are correct there. Yeah, someone's very excited about it. You can't start the shooter without having a shooter. Yeah, all of you guys in the chat are correct.
All right, cool. Claire, do you have any more questions to add to this?
I would like to ask, what happened to the execute method? I'm not sure if I see the execute method here. Wait, Lox, can you hear me?
Yeah.
Okay. Is there a reason it's not there? So we got some guesses in the chat. Alyssa said maybe a command base is a simple action so they don't need an execute. And John said maybe it only runs shooter.run once. Any other guesses or thoughts? Lox, you want to answer this one?
Sure. All right. So shooter.run, it triggers a method in the shooter subsystem class, and each of the subsystem class has its own periodic thing. So what this run method does is it tells it to go at a specific speed, and the periodic is similar to execute, that it runs in a loop cycle. So when a specific property gets updated in the subsystem class, let's say originally set speed was 0, but after calling run, set speed changed to 5,000, the periodic is going to make it go at that speed. And is finished is just checking if it's up to speed, and then once it is, it's going to end it. So execute, there is technically no execute, it's actually replaced with the periodic back in the subsystem class.
That's something you're good. That's something you want to think about, like when you structure your program. Where do you want to put certain things? And yeah, there's some more detail on like ways you can set up subsystems and stuff in resources that you'll be able to see later.
All right, so this should be good. Let's move on to another example. So here is a climb command. Basically uses the climber to climb, and ends when it
Wait,
is
Lox,
at the target.
did you switch the slides? Cause not showing up. Ah, there we go.
I did. Can you see it?
Yeah, there we go.
All right, cool. Yeah, so again, climb command, uses the climber, starts climbing, and is finished basically is at target. So again, can you guys identify which type of command this is?
Yep. So you got some command bases in the chat. Seems legit.
All right, cool. Second thing, any guesses for what's happening in the execute?
Someone said calling a function called climb in the climber class, identifying an action that has an input in the climber subsystem.
Cool, cool. All right, third
Calling
thing.
it. Calling an action that has an input in the climber subsystem. Yeah, so climb is a method in climber that does something, namely it runs the motor.
Yep. All right, and then third thing, let's say there was no end. What would the command do, or how would it look like?
So like what's happening in the end method, and if we didn't have that method, what would happen? No answers in the chat right now. Oh, we got one. It's shutting off the power, I'm guessing, and if it didn't have it, maybe the climber would never stop, never turn off. Any other guesses or attempts? Any thoughts? Yeah, so I don't. The climber would keep moving, but it's making sure that the climber is going to a level. Yeah. So I think both of you guys are pretty on it. As you can see, we have our is finished method, right? And in this method, we're checking to see if the so one clue that you can see is in our is finished method, we have a check that says return climber dot is at target, and we know that is finished is going to return either true or false, right? So we can assume that that's going to be telling us whether or not we're at the target. And we can also notice that in the end method, we're setting the powers to 0. In other words, like we're stopping the motor by giving it no power. And so like as this command is running, it checks like, hey, are we at the target yet? Are we at the target yet? Etc. Etc. And when the system goes, yes, we have reached the target, then is finished returns true, right? And then what happens there is it goes to end. And at end, we set the power to 0, we stop the climber. And Charlie, you have a good point too. You notice that end takes in a Boolean for interrupted. And so in this case, if it's interrupted, or if the command naturally stopped, we would set the power to 0, right? And if we didn't do that, then, well, although it is finished, we don't have an end sequence. So if there was nothing in the end method, then the climber would still keep moving, even though it had already reached its destination.
You might be kind of weird though. So maybe the subsystem class also has a periodic happening behind it, and that could maybe stop it if stuff's implemented in there. But in general, if it's not implemented in the periodic, it might go over the target, which we don't want. So it's good to end it properly in the end.
Mhm.
That's what's end for. Let's actually take one more question. So we are currently
Someone said, how would it even run the end method? Because that isn't called until is finished. If so, why isn't the Boolean parameter? Um, so is finished tells us whether or not to go to end, right? So when is finished returns true, or when the program is interrupted, the system will make sure that the end method gets called. That's like that in that thing isn't something that we have to code in. We just have to define what happens at each of those points. Did that answer your question, Avery? Not really. Okay.
well. I guess let's talk about how
So
it
the question
actually.
was,
What's
if
the sequence?
so, why isn't the Boolean parameter in is finished? Yeah, Lox, you wanna?
Sorry, what was the question?
So the question was, how would the program even run the end method? Because that isn't called until is finished is true, right? If so, why isn't the Boolean parameter in is finished? And if we change interrupted to true, why would that call the end method?
Well, all right. So the reason why interrupted is here is because you could do two different things. Maybe if it's interrupted, you can log that the command was interrupted and we never got to target. But if not, maybe just log that it ran successfully and set it to 0. Well, you have to set it to 0 either way, but that's what you could do. And just talking about the sequence of how stuff runs, it's initialized, then execute is finished, and an is finished calls that. So if is finished is true in the command based class, if this is true, then it just bounces onto the end and runs that. And that all stuff is happening in the command based class. So just talking about command based programming again, it's an example of definitive programming. So um, how the robot does it, but how it happens rather than when, or when it happens rather than how. Did that answer it? Did that help?
I think so. Right.
All
Cool.
right,
So,
cool. We can also take another question on that. So, let's say we're at the stage. Our target is 5,000, but we're currently, let's say, at 1498 or 44998, and every time you run execute, it goes up by one. And those are just now takes. So let's say target is 5,000 takes. You're at 4998, and every time execute runs, it goes up by one tick. How many execute cycles is it going to take to reach its target?
yeah. So, Alyssa asked, so there's two ways for end to be called: if is finished returns true, or it's interrupted by the scheduler. And yeah, so you would end this action, right? Either when it finishes naturally, or when someone else says, "Hey, stop it," right? So yeah, you're right. There are two ways for end to be called.
Do we have responses to the question in the chat?
Yeah, they said, "Gotcha, this clears things up." All right.
Cool.
So are we ready to move on? Thank you guys for all your questions.
All right. Well, thank you guys, and well, here's a link to more resources. There's links to the actual WPLib command-based programming sources, so you can read more about these concepts over there. And if you have any questions, now is the time. We can just have an open Q&A session.
Yeah, I realize this is a lot of information pretty fast, but if you'd like, we can link to the slides as well on that resources doc. There's WPILib. Yes, the session is recorded. I will. I believe I have your emails from the session signups. So if you'd like, I can send it to you as well.
Link to the video can also be included in the resources doc, and
Yep.
will be.
Right. Thank you everyone for attending. If you have any questions, feel free to ask now. I Alyssa asked, so how does the scheduler work? Oh boy.
You can screen share again.
Yeah. You want to pull up? You can pull up the flowchart.
Yeah.
Oh my god.
All right, can you see it?
Alyssa, can you see the flowchart here? Right. So yeah, we can walk through this sequence of events. Um, so Charlie also asked, in the scheduler, would you have an if statement with is finished, or would that be implemented in the command? So so basically like the scheduler isn't really something that you should be coding on your own. It's like in WPI that's something command scheduler that already exists. Yeah. So in your command, all you need to define is what is the marker for your command to finish, right? So you would just say, oh, my command will naturally stop if I drive to this location or if I move the arm to here, right? So when the scheduler schedules your command and the command is running, there's something built in already that checks, like it runs a method, is finished and checks if it returns true or false. Devin says, so this allows for long complex actions to happen with less input and clutter each segment. Yeah, I'd say so. Like for command groups, for example, you can line up a lot of things to happen in a specific order or in some other like routine, yeah. And similarly, like if you're thinking about mapping robot actions to like a keyboard press or a joystick button or whatever, this will help you do that as well. You can say, hey, I'm going to schedule this command when I press this button. So I guess I'm asking, so do you call the command in the scheduler or a robot class? Lox, do you want to answer this one?
Sure. Well, so scheduler is a basic thing. It's from the WPI lib, so it's generally in the robot class or another one. We can go into the specifics a little bit. So start would be, let's say, scheduler dot start or something. There's a method for that. And then let's say we press joystick button over here on our Xbox controller to, let's say, move the turret to a specific angle. So that what it does is there's a method in the code which says scheduler.schedule, and it takes in a command. So we would idly schedule turret.move to a specific angle, and that'll schedule it. And if it is scheduled already, then it does nothing. But if it hasn't been scheduled before, then it goes through these two checkpoints, and if both of them are yes, it runs the command. If not, changes it. So if requirements is not available, it depends if a conflicting command is interruptible or not. If it is, it runs the command. If it isn't, then it does nothing. So let's say turret is being already used by something else. Let's say vision was trying to align it to the target. Um, is vision interruptible? If it is, yes, then I can align it to a specific angle. If vision isn't interruptible, then where it's going to be cancelled and vision is going to keep running.
Yeah, does that answer your... What does it mean for a command to be scheduled? So when you schedule something, you can think of it as saying like, I'm planning on it running at this point, right? So, um, when you run a command, when you want it to run at a specific time or on a specific trigger, you need to schedule it, right? In other words, like preparing to run.
So the command itself is an action, but when you do the action is based on the scheduler.
like yeah, you have to define when to do this action, then that's what scheduling is. It's you choosing. Do you have an example of the scheduler?
I mean, I can
I
walk
mean,
you through.
if you want to pull up the docs on the WPI Lib official docs, maybe you could.
Yeah, that
That would
works.
probably be better than our modified version.
That is true.
Yeah. So like to be clear, the scheduler isn't something that you need to like code yourself. If you're using the WPI lib library, which a lot of FRC teams do, this is something that's already available. And to do it, you simply do like schedule command scheduler dot get instance dot
They don't
schedule.
actually have a schedule example, but yeah, there's a method called schedule, and that schedules your command.
Yeah. So like that's not something you have to code on your side, but like you can use this existing tool. I'm confused on how you determine if a command is interruptible. Lox, do you want to pull up the like types of commands? Because there's like there are specific types of commands that you can define as able to be interrupted.
Right. Well, do they actually have examples for that?
Um, if you search interruptible, are you sure? Not found?
No.
Hmm.
All right, here there's a with interrupt.
Yeah. You can also look at like the source for like the command base class. But yeah, you can define that whether something is interruptible or not. But I think by default they are interruptible.
Yep.
It's only the commands that are like you say run this command the entire time. I'm pretty sure those aren't interruptible. But I could be wrong.
Which I believe is the run command. So
Yeah,
it
you
runs
can.
throughout the command.
There's some like I think by default you can interrupt a command, but there's some specific subtypes where I don't know if it's different. What happens if a scheduler isn't able to schedule a command? Does it just skip over? Yeah, so if you look at this flowchart, if it's already scheduled or there's something that's keeping it from getting scheduled, the command doesn't run, it doesn't happen. Eddie says, can you go back to the 4 types of commands slide? These are the ones that we put here are like some of the highlights, although I'm pretty sure there's a few more versions that, yeah. These are some of the main ones that you'll probably use.
Yeah.
Again, if you want to read some of the details on them or like get some code examples, how to implement them, etc., the WPI Lib docs website is very well done. Right. Right. Do we have any more questions? Feedback, comments, anything? in that case, I'm gonna pause the recording then.